Welcome to the Crazy Hat Chemist. So we're doing another video on thermochemistry. So let's get moving. Bam! Hess's law of heat summation. So I'm going to give you a definition here and an example and also an analogy. So let's get moving on that. So Hess's law is the algebraic sum of two or more reactions and this sum is no different than if the reaction were to occur in one giant step. Okay? This concept allows one to calculate delta H naught of formation values that are difficult to experimentally determine via this indirect approach. So here's a switchback of a mountain. This will be our analogy. So if you're going to climb the mountain pass via a cable or one-step process, that's from the bottom here of this switchback all the way to the top. So do you see that blue line there, hopefully? Okay, that is one path that you could take. Another path is climbing this mountain using the switchbacks and taking rests along the way. This is a multi-step process. So follow me as I go through this multi-step process up this mountain right over here. Okay, awesome. So that same multi-step process and the cable, it doesn't matter which one I take because both processes start and end at the same place. If they start and end at the same place, then that is a state function. Okay? And that allows me in one step with the blue line to do the problem all at once. Or with the orange process to do it in a multi-step function. Okay, there are many reactions of which we cannot do actually in just one step, but we can do them in a multi-step fashion, and that's why the switchback works very nicely. By the way, that's a nice example of a bicycle race in Italy. That's what that mountain pass is from. So, Hess's law of heat of summation, here's an example. Going from carbon solid and oxygen gas, those are the reactants, all the way to carbon dioxide. That requires a delta H of negative 393.5 kilojoules. Now, many times we can't do this all in one step like I have here with the blue line, just like the previous blue line with the cable and the mountain. So we might have to do this in a multi-step process. This is going to take two steps. I'm going to take the carbon and oxygen gas and go to carbon monoxide and then oxygen gas. And then from that, I'm going to go all the way to carbon dioxide. If you see, this orange two-step process is the same as far as the delta H overall. So I'm actually summing the two reactions up and I get the same result. Another example of a state function is your bank account. If you have $1 in your bank account, then if you add 1 penny for 100 days, you'll get $1. Or you could add $1 in your bank account all at once. It doesn't really matter. Your bank account is a state function. The start and the end is going to be the same. How you derive there, it doesn't really matter. Okay, that was another video here, and I've got a turkey on my head. So, don't be a turkey. Give me a thumbs up if you like that video. Don't be a turkey, and please subscribe to my YouTube channel.